Hello everyone, and thank you for joining us for today's webinar. Today I'm going to be discussing best practices for using markups in 3D printing, and particularly with Rise's technology. My name is Neil Foley, and I'm the applications engineer here at Rise. So I will begin by talking about some of the useful applications of using the markup technology. So to begin with, markup technology is the ability to apply ink to the surface of 3D printed parts, and this is useful for a variety of different things, all built around essentially attaching information to your physical printed parts. So some of the things that you're able to do with this are tracking iterations, versions, and serialization of your parts. So this could be in cases where you're going through many iterations of a single type of part, and in order to keep track of which version is which after you've completed the print, then having a markup on each part using the serialization function or by individually attaching a markup number, it's more easy for you to return to previously printed parts and recognize which iteration it belongs to. Another thing that you can do with this is do what we call simultaneous iteration, where instead of printing one iteration at a time, checking it, and then making adjustments and trying another, you could apply markups to multiple different versions, different possible solutions to a part that is being prototyped, and after printing all of them, you will have the proper iteration or version identification number on every part that comes off, and then you can print them simultaneously, test them simultaneously, and then accommodate whatever you learn from those tests into your next round of iterations. The other thing that this is useful for in that vein is to apply part numbers, author names, dates, and various other metadata to a part, and this is useful for similar reasons, just being able to track the vital information about where a part came from and what it's for. Another useful thing is applying logos and other images. This can be especially useful for branding in the case of marketing or sales tools, where it allows you to put your company logo on a part, ensuring that if it ends up traveling outside of your company, it will always be identified with its source. Also, you can use markup technology to apply instructions such as assembly instructions or instructions on how to use a part, and this can be helpful in cases where a part is being passed around to different people who all need to be able to use it properly, and this can ensure that a part is used in the proper way without each user needing to look up or ask about the proper usage of it. Another useful way of using markups is for component alignment, where you have assemblies of multiple parts, and markups will allow you to place callouts on the surface of parts to ensure that the components are assembled or related to one another properly. And finally, you're able to use markup technology to create QR codes, which are useful for a whole variety of other things, many of them similar to what we've discussed already on this page, but oftentimes you're able to pack a lot more information onto a part by using a QR code than by using standard text. So a final feature of markups that is useful for many cases is the fact that the Rise markup technology embeds the markup ink directly into the part using a dye and a solvent, and that prevents the markups from being rubbed off or scratched off. So it's not just a surface feature, it is embedded into the plastic. So the plastic itself would have to be scraped off in order to lose the markup features. So this slide demonstrates essentially how Rise accomplishes the markup feature in our technology. We use a patented process called augmented polymer deposition, where we combine material extrusion and material jetting into a single hybrid system. And combining these two features allows us to accomplish a variety of different things. Typically, the way that a print on a rise machine will work is that you will start by extruding thermoplastic on the bottom layers, and this will create a raft and the supports required to hold up a part as you build overhangs and cavities. Then we jet a special ink that we call a release ink on the top of the support layers. And this is a special lubricant that allows the support to easily detach from the model structure despite being printed in the same thermoplastic material. And then as we extrude the remainder of the thermoplastic material into the structure of the part, we're able to jet other functional inks, including in this case marking ink, in order to achieve different effects such as creating text and images on the surface of parts. So some of the things that you'll want to pay attention to when using markup with Rise technology are, for one thing, the print head alignment. In order to ensure that you'll get the best quality from each part that you print, you'll want to make sure that the ink head or the print head for the ink and the extrusion nozzle for the thermoplastic extrusion are properly aligned, and there is a process for this to be accomplished built into the Rise system. In cases where this alignment gets out of line, you can have cases where the markup is being jetted off of the part and down onto the raft, or missing the surface that it's intended for. So this is one thing that will be involved in maintenance occasionally. Another thing to pay attention to is resolution. So our software has a built-in markup feature that allows you to apply markups onto the surface of parts in software, which can then be translated into the creation of markups on the physical part. And this feature allows you to lower your text font down to a font size of 6, and this will still be legible in most cases. Certainly legible on top surfaces, which produce the clearest text and images, and it's also still legible on side and bottom surfaces. And it's even possible to go even smaller than that, but there is a limit to how fine of a resolution you can get. And that's just one thing that you'll have to pay attention to make sure that the markups that you produce are able to be read and used. Another thing to consider is surface selection and orientation. So this refers to the fact, as I alluded to a moment ago, that depending on the surface that you print a markup onto, you may get different sorts of qualities. So some of the things you'll want to pay attention to are the fact that the vertical resolution of a thermoplastic extrusion printer like Rise is limited by the layer height in the vertical direction at which it's printing. So on the Rise machine, this would be either 250 or 125 microns, and because of this, you won't be able to get a vertical resolution in your markups greater than this when printing on a side surface. Another thing to be aware of is that on shallow slopes, you may see some stepping because of that same vertical printing resolution limitation, where for very shallow slopes, it won't be able to resolve the shallow slope entirely, so there will be steps separated by distance, and when applying markups onto these surfaces, in most cases it's not a problem, but in some cases where you have fine details, it can be more difficult to get a good quality markup because of the sort of jagged appearance of some of the stepping. Another thing to pay attention to is that on inverted slopes, the print head alignment becomes especially important because you're sort of jetting over the edge of a cliff and need to get it right on that edge. So what I mean by this by inverted slopes would be a slope that is overhanging, such that when you print at the edge to apply a markup to the surface, there is very little material directly underneath the print head. So if the alignment is off, you can wind up with ink being jetted off of the edge of that overhang and onto the part below. Another thing to be aware of is that the primary material that we use at Rise, Rhisium-1, is very chemically resistant, and so we have to use a specific special chemical that we call D-limonene in order to glue parts together, and it's also useful for several other applications, including smoothing parts. One thing that it's useful with regard to markups is being able to remove unwanted markups or spots of ink. So the D-limonene is able to partially dissolve the surface of the part, and this allows it to sort of weld pieces together when gluing, and that's also what allows it to smooth the surface if that's what you intend to do with it. One of the sometimes unintended effects of this is that it also dissolves the portion of the plastic that contains the marking ink, and because of this, that can cause the marking ink to smudge. So if you do intend to apply a markup, or you do intend to use D-limonene to smooth a part, then you'll want to make sure that you're not doing them using those two things on the same surface, or else you may find a smudge. However, the D-limonene can also be useful for actually removing a markup. And the best way to do this is to put a few drops of D-limonene onto the markup that you'd like to remove, let it soak for a little while, maybe a minute or two, and then dab it off, and then maybe apply another few drops and do that a few times to remove it as well as you can. One other best practice I have listed here is applying markups to hidden surfaces, and this is just one capability that I will be discussing on the next slide, where you are able to, in fact, produce marking ink markups on the interior surfaces of a part that has overhangs or cavities. So we'll be looking at that in a moment, how to implement that. So starting in our most recent software update, which is called OneTouch 1.5.0, there is a new version of the markup feature, and it has a few useful properties that I'm going to be demoing in a moment. Some of these include the ability to orient or manipulate a part directly for the purpose of applying markups without necessarily reorienting it on the build plate. We've also added functionality to apply serial numbers, which can automatically increment themselves as you add instances of a part to the build. We've also added image wrapping, which allows you to apply markups that will curve around a part rather than stretching at the edges, which would happen if you were using a direct normal projection. And finally, we have added the ability to modify or delete markups, which allows you to replace an image or text markup that you've applied to a part without having to restart with applying markups. So now we're going to take a look at this part in software. So you can see here there's this markup button at the top left, and if I click it, it will now bring me into markup mode like this. And now I have a variety of different options. As I mentioned, I have the ability to rotate a part within markup view like that without affecting the way it's oriented on the build plate. So what I'm going to do is give us a front view, and then I'm going to apply a few markups onto the surface of the part to demonstrate. So we can start with a text markup, and I'll just type out some text, and then we can apply it to the surface of the part like this. Now you'll notice that it cuts off at the edges because of the way that it's stretching around the curved surface. But what I can do next is select this part or select this markup and delete it. And now if I try that again, I can look at these options over here. Currently it's selected to project straight. I can instead choose to wrap around, and there are a few options here. You can either have it keep the same width that it is currently scaled to, or you can aim to wrap it exactly halfway or all the way around the part. So I'm going to try wrapping this 180 degrees, apply it, and now it does do a bit of stretching in order to reach that 180 degrees, but the stretching is consistent for all of the letters. It isn't stretching more at the edges and less in the middle. So I could play around with this and scale it a bit differently in order to get the letters to appear unstretched. Another option that we have, I'll apply this one to the back, is to add pictures. So I'll grab this logo right here, and I'm going to try doing the same thing. I'll scale it to about there and wrap it around 180 degrees, and there it goes. And so you can do this with not only text, but with images that have different scales of darkness, and this could allow you to put more complex images onto more complex geometries and achieve a variety of different useful effects. So now if I exit markup mode, see that the part is still oriented as it was, and the two markups that we've added are added as we told it to. Now I can actually go back in if I want to and select these and modify them or delete them, or add additional ones, and these will remain here even if I save the file, close, and re-enter it. I'll be able to continue editing these in the future. Now I will head back here and we'll move on to another topic. So one of the special cases that I mentioned is QR codes, and QR codes are very useful for applying information to a part when you want to have a high density of information, or if you want that information to only be accessible to a limited set of people. So some of the things we mentioned previously, part numbers, version numbers, authors, dates, machine of origin, all of these can be applied using a QR code instead of putting text all over the surface of a part, and this can reduce the amount of real estate required to store that information on the surface of your part. Some other things that you can use this for include dimension callouts and tolerance data. There is a difference in the two main ways of using QR codes. One of those is called static and the other is dynamic. And a static QR code will just have text stored directly into it so that when you scan the QR code, it will give you the text. Dynamic codes will instead link you to a URL, a website address, and using this website address, you can dynamically affect what content is linked to your part. And so in this way, you could attach instructions or documentation on the part that evolves over time as it's produced or refined. You could also use marketing links that go to a company website with a dynamic set of messaging, and anyone who scans that part will be brought to the most relevant information on that website at that moment. Another thing I mentioned is secure web linking, where not only are you able to attach large amounts of information using this dynamic method, where the only information required is the web address, but by using a web address that is behind a login wall, you're also able to store various information that will not be accessible except to those who have the authority to view it. So this can include things like files that are on your network or within your PDM system. It can also include secure or confidential annotations related to a part, or the customer or patient metadata associated with either the patient, perhaps that a medical model was produced from, or a customer that has requested a certain part and has confidential uses for it. A final thing I have listed here is tracing and authentication, which is useful for ensuring that a part that you produce cannot be produced by anyone else without the sort of authority to prove that it's theirs, in a sense. So this allows you to track parts and also verify the source of a part and make sure that all of the parts that you're producing are controlled in this way. So here we have a short video, and this will be demonstrating the use of QR codes with first Rise software and then actually scanning the code on the part it produces. So first, we'll be applying a code using the markup feature. This is an older and simpler version of the markup feature. Now it slices the job and prepares it for printing. And now once the part is completed printing, you can use a scanner app on your smartphone, and it brings up the information that you've attached to that QR code. So now I'll talk a bit about some of the best practices involved in applying QR codes. So first of all, regarding creating and scanning QR codes, there are resources available in many different places. You can just essentially search for them on the internet or the App Store for your phone to find the proper software to use. If you have an iPhone, you have a QR code scanner already built into your camera application, so you won't need that. Next, we have the difference between plain text or static QR codes versus web addresses or dynamic, which I've already mentioned previously, but one of the important things to pay attention to about both of these is that the less text that you attach to a QR code, the easier it will be to scan it, because the fewer pixels you will have to be able to read. And the more pixels you have, the more likely you are to reach the limits of resolution on the particular application that you're using. So if you're, for example, using a web address, you may want to limit the size of the limit of the web address as much as possible. Remove any unnecessary characters such as www. And that can prevent you from producing too large of a QR code and being unable to scan it. Some of the other things I have listed here include some things you'll want to pay attention to when applying QR codes. So one of those is surface distortion. So the images at the top show what would happen if you attempted to apply a QR code in the orientation shown on the top left. And when you would then go to scan the QR code, perhaps in the orientation on the top right, you would find that it is much too distorted for your scanner to read. So when applying a QR code to the surface of the part, you always want to select from front surface, and this will ensure that it won't be distorted in this way. Now on the bottom, we have a QR code applied to a curved surface, and this can in some cases work if the surface has a very shallow curvature and the QR code does not cover much of the curve. In most cases, though, it's best to only stick to flat surfaces. This will prevent this from being an issue when you go to scan the code. few other things include obstructions, error correction, and the white boundary, and these are just a few other things to be aware of when applying QR codes. So you'll want to make sure that when you apply the QR code to the part, that it's in a position that you will actually be able to scan it once you've produced the part. So a QR code on the inside of an internal cylindrical surface, as shown here, may be more difficult to scan because you'll be scanning it from an angle. The white boundary is something that's also necessary for most scanners to be able to isolate the QR code. So this is the track of white on the outside edge, shown in this bottom left image here. And if that boundary is not there, such as on that same QR code within that cylindrical surface, because that's right up against the edge, it may be more difficult for the scanner to isolate the QR code and then read it. And finally, one of the benefits of QR codes is the fact that much of their internal data is in fact error correction. So in some cases you can actually have a QR code print incorrectly with as many of it as 30% of its pixels incorrectly marked, and it may still be possible to read it. So this can sometimes be helpful if you have a case where you can't get a complete square large enough to apply the part and you need to cut a piece out. So now I'll just go through a few quick use cases of QR codes. So here's one case that you could consider. So during a prototyping process, when a part or assembly is iterated through many versions, applying QR codes to each printed part can help to keep the iteration straight. So a QR code on each iteration can be used to document not only the versions, dates, printing parameters, and design changes, but things like changes in the way that the part is used and changes in the result of the verification process and much more. So for example, if you've printed several versions of a part where each version requires only a slightly different hole size, then just by scanning the QR code, a linked database can tell you the dimensions for each part, and it could even connect you directly to the model file. So this method can also document the relationships of an assembly among parts with different version numbers. And linking a code to your PDM system could allow a collection of printed parts of different version states to document their assembly state dynamically, rather than requiring you to reference and sort through an assembly tree for every part. Another benefit of this approach is that by linking to a database, in addition to changing the assembly relationships among the parts dynamically, a part can be digitally obsoleted, and that information will be available on the printed part itself. So after scanning the QR code, it could then give you the most up-to-date information about whether that part is still to be used in a given assembly. So for parts being produced and used at high volumes, this dynamic linking capability could allow you to instantly revise the linked instructions for every instance of a given tool or component. And here is one other use case for 3D printing QR code technology. So for a variety of different medical reasons, doctors will use MRIs and CAT scans to model the bones and other organs of their patients. Printing these models in 3D is useful for visualizing the problem during pre-surgery planning and can also enhance doctor-patient communication. QR codes can be a very effective tool in this case, where a QR code applied to the surface of a printed model can link that model to a database of information about the patient, their medical condition, and the scan metadata of this particular model. Most importantly, that type of data is confidential, and linking the QR code to a secure database gives doctors convenient and organized documentation of the printed patient models, but it prevents unauthorized users from accessing a patient's personal information, even if they happen to have access to the physical printed part. So this approach would build trust, traceability, and confidentiality into physical parts, which is valuable not only to doctors, but also to any organization with confidential or classified documentation of physical parts, whether they be models, prototypes, or tools. So most of the markup technology that I've discussed in this webinar has related to our Rise 1 3D printer, which has a single color of marking ink and applies it in monochrome. So you can still, of course, get different shades of it, but you are basically just using the white base material with a blue ink. Our next generation printer, the X-Rise, will have additional colors of inks that will allow you to print the full spectrum, and this can produce much more vivid and complex printed images and even text, and that's useful for a variety of different applications. So some of the ones we have shown here include simulation visualization, which is useful for various forms of engineering. It can also be useful for geographic and architectural models, which is useful not only for geography and architecture, but also things like surveying and some military applications. It can also allow you to produce high fidelity packaging and product design prototypes. And it can also help with some different models, including medical models or marketing and sales models, which can be used as sort of sales tools. So that's all that I have for today. Thank you all for joining us for today's webinar.